Yeah, after taking that easy example of methane where it was very easy to write the electronic dot structure, let's take a little bit complicated molecule, which is carbon dioxide. When I say complicated in terms of writing the electronic dot structure. So carbon dioxide, as the name suggests, a carbon and 2 oxygen atoms. So writing the electronic dot structure for this one. So I have written down some steps which we can follow one by one and successfully write the electronic dot structure, although I will be adding some more stuff with even more complex molecules. So first is to calculate the number of valence electrons for the molecule carbon dioxide, and I have already discussed that with you. You go with the individual valence electron of the individual carbon atom and you individual atoms in a molecule, and then you add it up. So there are 4 valence electron in carbon, and then since there are 2 oxygen atom, I am writing 2, and on each of the oxygen atom we have 6 valence electrons. So you have 2 times 6. The reason is just simple because there are 2 oxygen atom in there. So the number of valence electrons contributed by oxygen to carbon dioxide is 2 times 6. So 2 times 6 is 12 plus 4 is 16. So that means there are 16 valence electron in carbon dioxide. And writing electronic dot structure is nothing but arranging the 16 valence electron around the carbon dioxide molecule. So that's the first step. So we have done the first step. In the next step, we have to determine which is the central atom and which are the terminal atoms. And that's very simple over there. And I have discussed that too here also, that the central atom is an atom which is present in fewer number in that molecule. And there are some exceptions too, but we are going to discuss as we progress in our lecture there. And the other thing is the central atom is an atom which is of lesser electronegativity, which has lesser electronegativity than the other atoms in the molecule. So when I consider these 2 factors, then carbon comes out to be the central atom, because first is present in fewer number, just 1, and whereas on oxygen there are 2 oxygen atoms. The second is carbon is to the left of the oxygen atom in the periodic table, so that means it is less electronegative than oxygen. So carbon is the central atom. So once we have done that, we have identified the central atom, then it becomes very easy that what are the terminal atoms. The rest of the other are the terminal atoms. So the terminal atoms you're going to write it in a way that they surround the central atom. And in the third step, what you have to do is you have to arrange electron in such a way that the octet on the terminal atoms is complete, and I've already explained what that octet is. The octet is the presence of 8 electrons on any atom, right? So for doing that, the first step is just join the 2 oxygen atom with the carbon atom. Now what this joining means, as I've already said, this is a bond, and this also represents that there are 2 electrons in between carbon and oxygen, 2 electrons, carbon and oxygen. So the best way is just show a line. It's by convention know that a line represents 2 electrons. And now I have to arrange the rest of the electrons in such a way that the octet on oxygen is complete. So I'll start with one of the oxygen atom. I will put these dots in pairs representing a pair of electron. So I have 2, 4, 6 and 2 in between carbon and oxygen. So in total 8. So the octet on this oxygen atom is complete. In the same way, I'm going to do it on the other oxygen atom. And here also 2, 4, 6 and 8, the octet on this oxygen atom is complete. So in total 8 on this oxygen atom and 8 on this oxygen atom. So I've already accounted for 16 valence electron, and there are 16 valence electron here. So that means I don't have any extra electron to account for carbon. Now what this electronic dot structure states that it's not only the terminal atoms whose octet should be complete, but also the central atom octet should also be complete. That means the central atom should also have 8 electrons on it. And if I count right now here, the central atom, which is the carbon atom, has only 4 electrons on it. 2 here and 2 there. So there are only 4. So how do I account for 8 electrons? How do I arrange the electrons, these 16 electrons, that carbon 2 has 8 electrons? So one way of doing that is that you move any of these electron here, which is concentrated on one oxygen atom, in between the oxygen and the carbon. So you move these 2 electrons from this to this position, and in the same way, on the other oxygen atom, you move the other pair of electron in between the carbon and oxygen. When you are going to do that, what you are going to get? So let me write this here. So you have carbon, you have oxygen, and you have arranged 2 electrons from this position to there. So you have 2 electrons there, and then you have a bond, then a bond, and 2 electrons. And 2 electrons always corresponds to a bond. So instead of 2 electrons, I'm just going to represent it with a bond. And then what is left on the terminal oxygen atom is this thing. Is this thing, right? So let's see. On the terminal oxygen atom, how many electrons I'm seeing? 1, 2, 3, 4, 5 and 6, 7 and 8. So the octet on the oxygen atom is still complete. And in the same way, on the other oxygen atom, 1, 2, 3, 4, 5, 6, 7 and 8. The octet is complete on the other oxygen atom too. So let's see if the octet on the carbon is complete or not. So 1, 2, 3 and 4, 5 and 6, 7 and 8. The octet on the carbon atom is also complete. 4 there on the left side and 4 on the right side. I again repeat, these bonds here, these straight lines represents 2 electrons, a pair of electrons. So this is the electronic dot structure of carbon dioxide. I can redraw it in this form. You have carbon, and the carbon is bonded to 2 oxygen atoms by the bond which we now call a double bond. It's no longer a single bond, it's a double bond. A double bond, and the oxygen has 4 other electrons which are arranged in pairs. So this is the electronic dot structure of carbon dioxide. This we can get more information from this structure. One, that these bond here or these electrons here are called bonded electrons. Bonded electrons means the electrons which are participating in the bond formation. The electrons which are in between the 2 nuclei. In this case, these 4 electrons are in between the oxygen nuclei and the carbon nuclei. The other 4 electrons here, which are also the bonded electrons, they are being shared by the carbon and the oxygen nuclei. So those are the bonded electrons. So what are these electrons called, which are localized on a single atom? These electrons are called lone pair electrons. These are called lone pair electrons. That means they are localized on a single atom. These pair of electrons are also called, the lone pairs are also called non-bonded electrons. Non-bonded electrons. The reason is simple, that these electrons are not participating in the bond formation. So this is the complete information we get from the electronic dot structure. We can take some more examples and discuss the arrangement of the valence electrons on it.